All right, is this all running? Okay, well, hello everybody. Welcome back to some, I guess, atypical COVID quarantine style math class. Today's our first unit, or I guess rather first day, starting on a new unit on right triangle trigonometry. It is going to be our last unit for the entire year. It's going to correspond with chapter 9 in your book. So that thing you took way back in August that you should hopefully just be, I don't know, maybe it's collected dust this whole time. Might be worth, I guess, dusting that off. You're going to hear me refer to it likely as trig at some point. It is shortened for trigonometry. I should probably always say trigonometry, and I apologize if I end up not. This is a very, very deep vein of mathematics. We are basically just starting sort of the surface level pieces of this. It is critical for success in Math 3. Which is why we're focusing basically the rest of our time this year on this unit to try and get you as successful as possible so that Math 3 is hopefully an easier process, okay? Excuse me. Everything we're going to deal with is going to be all around right triangles, so something that's got a 90-degree angle. You're also going to see something a little bit different about these two, because I can't physically print you a toolkit. I'm going to try and sort of color the slides that would be like what I would basically make into sort of toolkits. I'm planning on probably releasing the slides as PDFs afterwards, so you're welcome to those if you wanted. You can kind of take and pull from them. You could print, I guess, if you really wanted, if you wanted to write your own, whatever works for you. But I would have gone with green sort of for this unit, so these green slides are going to be sort of the real critical ones here, okay? Pythagorean theorem. Ideally, not a new skill, something that we've sort of seen before, but as a quick refresher, I'm going to kind of highlight a few things here, okay? In a right triangle, we're going to have two parts. We're going to have legs, of which we have two. Those are going to be the sides that always touch the 90-degree angle, okay? They're going to correspond to both A and B in your Pythagorean theorem. And then your hypotenuse is the side that I would say is opposite from that 90-degree angle. Like this 90-degree angle is open pointing toward that hypotenuse. That's how you can always tell. Your hypotenuse should always be the biggest side length. Always, 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 always. Your hypotenuse is going to end up being the C letter right here. Okay? Let's actually try it. We'll come back to this Pythagorean triple, but just work our way through this first one. Kind of a refresher. I want you to find x. So we're going to do a little bit of algebra using this Pythagorean theorem. What I would have, I'm actually going to type this out. Be a little cleaner. If I had my same formula, a squared plus b squared equals, oops, sorry about that, c squared. A and b, as we stated earlier, are legs. C is your hypotenuse. So if I took this whole piece, copied it, and replaced the portions that I currently know, I have two sides that are touching that right angle. Those are going to be my legs. I'm going to replace the A with a 5 and the B with a 12. You could swap the order. You could say 12 squared plus 5 squared equals C squared. Great. Not going to make a difference. I'm going to go ahead and just clean this sort of thing up. This is going to end up being a 25. This ends up being 144. There we go. If I add these together, that's going to give me 169. And then the next part I'm going to have to try and sort of write out here. Think about the algebra I would do to get by itself. Hey there, Collier. You're hanging out in the Math 2 lesson, but you're certainly welcome to. I'm going to take a square root of both sides. That's going to cancel this guy out. Square root of 169 is actually a nice pretty one. That's going to give me 13 for my C value, which is, or in this case, C is basically sort of our X. I could have changed that as well. You might be wondering, well, hold on. You're always super particular about plus or minus a square root. Since this is a side length in a triangle, a negative doesn't make sense. So all of these are always going to be positive values. They're never going to change. So there's your value of X. In this case, I called it C because it stood for the hypotenuse, but it's still this same length right here. What's that guy going to be? There's your 13. Now it talks about a Pythagorean triple. Pythagorean is basically just a guy. Pythagoras was a Greek guy, a pretty famous mathematician who figured some of this stuff out. we have a big old list of like nice, what I'm going to call pretty Pythagorean triples. They're numbers that if you use them in the Pythagorean theorem, you don't get any gross square roots, because we're going to get a lot of square roots here. It's going to get kind of wild for some of these. The most common you'll probably see are a 3, 4, 5 and a 5, 12, 13. As a reminder, that biggest one, this guy right here, that end number is always going to be the hypotenuse. These other two are these, but you're not going to really see too many of these that are very far beyond that. Okay? Come back to this slide and reference it if you'd like. You do not have to memorize them. You can do the entire unit without them. Sometimes it's nice and handy. If you recognize you've got like a leg of 3 and a hypotenuse of 5, my brain automatically goes to a 4 because I've just been working with these for such a long time. Oh, so back to the previous guy. Was that a Pythagorean triple? I've got a 5, a 12, and then this guy was 13. That's our second option right there, 5, 12, and 13. We're basically doing the same style problem that we just did. However, slight difference. Our unknown variable here, it's one of the legs because it's touching that 90. So I'm still going to set up my same formula, a squared, if I can type that right, nope, plus b squared. Sorry if my keyboard's a little clacky, it's individual switches for all that, I'm particular about that. In this case here, I'm going to kind of copy this and then go through and edit. I have one leg, and I usually always just replace a, 7. My other leg here is x. I don't know what that guy is. And then c is going to be 14. That's the hypotenuse. It's opposite from that right angle. I'm going to clean this guy up. 7 squared is going to be 49. 14 squared is going to be 196. Oops. Move that back down. And now we just got to keep solving. You might think, well, what am I going to do here? I'm going to subtract a 49 from both sides. Let me pull up the calculator here real quick. Maybe. There we go. What's 196 minus 49? Again, calculator's totally okay with all this. I got no problems with those. That's going to give me x squared now equals 147. Same deal. I'm trying to figure out the value of x. This is going to make this true. Take a square root of this, square root of both sides, really. I'm going to change to a different color to kind of cross-cancel this piece out. That's going to give you x equals, leave it, is square root of 147. It is a number. If you really want to know what it is, you can figure it out, but, oops, sorry, let me clean this up. I'll show you. 147. Let's take a square root of it. And it's 12.1243, all the shenanigans. I'm not going to expect you to know that. We'll be a little more clear as we get closer to the tests if we want decimals, or if you just leave your answer as square root of 147, that's totally fine. It makes sense that it's less than the hypotenuse, 14, that leg, or sorry, the leg here, x, should be smaller than the hypotenuse. Both of them should be, and 12 is less than 14, so we're all good to go. This is an okay answer. I would stop there and just be done. So that one definitely wasn't a Pythagorean triple. I've got sort of, oh, I should have been saying what pages I was on. Way back at the very beginning, we started with page 518, example 1, if you'd like to sort of follow along in the book. The problem that I just did was page 518, example 2. Now we're going to look at the stuff on page 519, some monitoring progress, problems 1 and 2. These ones I'm basically just going to sort of solve. I'll narrate what I'm doing, but it won't be quite as in-depth as the others because it's the same stuff, just a little more practice, I guess. Let me go back and copy this, though. Always going to start with my Pythagorean theorem. We're bringing a bunch of algebra into everything. So for this first one, number 1 under monitoring progress, I notice that x is my unknown. I'm going to replace that for my c value because it's my hypotenuse. I know my legs. I've got a 4 and a 6. If I square those, 4 squared is going to give me 16. 6 squared is going to give me 36. Oops. Some weird sizing there. Add those together. Again, I'll bring the calculator on screen so you can see what I'm doing. I get a 52. So at this point, I now have 52 equals x squared. Got to switch over to the pen because I can't do a good sort of square root. I'm going to square root both sides because that's going to cancel this 2 out right here. My final answer is going to be square root of 52 is x. Okay, you could figure out what that number is if you want. It's going to have to be bigger than 6. I'll show you that it is. If I take the square root of 52 now, right, 7.2, which makes sense. It's the hypotenuse, it should be bigger. You can leave it as square root of 52, totally fine with that. If we do this next one here, number 2 under the monitoring progress, I notice that my unknown is one of my legs. This time I'll make it A instead, right? I'm going to change my B value to 3 and C to 5. I'm already thinking, since this is a leg, my answer should be something smaller than 5. If I clean this whole thing up, 3 squared is going to give me 9. Oops. 5 squared is going to give me 25. Uh-oh. Sorry about that. Let's just do this a little differently. I don't know why it's being particular. If I solve for x, what am I going to, or x squared rather, I'm trying to ultimately solve for x. Subtract the 9 from both sides. We're going to get x squared is 16. Take a square root to isolate the x. You're going to get x equals 4. I've got a 3, 4, 5 here. That is a perfect Pythagorean triple. This other guy ended up being a 4, 6, and then square root 52 for those lengths. You can have some practice, some homework with those, but this is the process. We could really only ask you for a leg or a hypotenuse. That's about it. Got another teal sheet right here. We're going to be looking at page 520, example 4. This is one of the sort of the toolkit guys. We can take the Pythagorean theorem and flip it around and basically test, does this equation, c squared equals a squared plus b squared, work? If so, the triangle is a right triangle. We also start to see now the introduction of some of these weird roots already labeled in side lengths. I'm going to show you how to handle those. This is going to be part of the expectation. We can do it. All right. I'm going to take my same formula here, and in this case, I'm testing if this is true. I'm not going to do any algebra. I'm just going to put in numbers, clean it up, and see. If I get a true statement by the end, then I have actually a right triangle, meaning the right angle is going to be sort of the one opposite the biggest side, the square root of 113, or it'd be like right here in between the 36 and 15. Again, page 520, example 4, if you're following along. I'm just going to copy this and start substituting some values. You do have to do a little bit of analysis to realize which ones would have to be the legs and which ones would have to be the hypotenuse. This is going to be a little weird here, okay? I'm going to put space and then 113. And what I'm going to try and draw here is a square root symbol. So I have the square root of 113 squared, because that's how long it is. If I start cleaning this up, the square root and the squared for that 113 immediately cancel. So now I'm going to have 113 on the right side. If I clean up the left side, 8 squared is 8 times 8, which is 64. 7 squared is going to be 49, because it's 7 times 7. Let's add these together. Clear that out. If I do 64 plus 49, 113. So my left side is going to be 113. Does that match the right side? 113 does indeed equal 113. What does that mean? The triangle is right. That's not some wordplay like the triangle could be wrong otherwise. This is a triangle. I know I've got a right angle right here. I'll even draw it in between the 8 and 7 across from that square root of 113. Let's repeat the process over here for B. Again, visually, it looks like we might have a right angle between the 36 and 15. 4 root 95 is going to be a little bit weird. I'm going to show you how to handle that. These numbers are going to get a little bigger. We're definitely going to use a calculator for this guy. I'm replacing A and B with 36 and 15. C here is going to be a little wild. So what I'm going to do, I'm probably going to have to write this one out by hand. So I'm going to write, I've got 36 squared plus 15 squared equals 4 And then I have the root of 95 squared. But I'm going to put all that guy in parentheses because I need to. These pieces are being multiplied. It might have been a while since you did properties of exponents. What I'm allowed to do, though, is take this squared to both pieces. Meaning, I'm going to have something that looks kind of like this. I'm not messing with my left side of my equation right now. My right side is going to give me a 4 squared times a square root of 95 squared. Do you notice how I can do a little better job of that too? Oh no, it lost it all. 4 squared times the square root of 95. Let me wait a second so it registers it differently. Squared. They were initially multiplied. I intentionally wrote that in here. If I clean up this next step, well, it's going to be a little interesting. This 2 for the squaring of the square root of 95 and the root will cancel out, leaving me with just 95. 4 squared on its own is going to be 16. So if I basically bring this piece down, what I now have is going to be a 16 times, because it was still multiplied, when I cancel the square and the square root, I just have a 95 right here. Now, these are large numbers, but that's okay. Let's use a calculator for it. 36 squared, I don't know that one offhand. Oh, of course it's 1296. So, what's 15 squared? That one I do know. So we're going to have 1296 plus, ooh, this is going to take a little bit of space here for this one. 15 squared ends up being 225. Check it home if you'd like. Come on. There we go. What's 16 times 95? I don't know that one either. $15.20. So replace that with 1520. Now I'm going to basically just add these last two numbers and see what we get. If I do 1,296 plus 225, I get 1521. Does 1521 equal 1520? Nope. That means this is not a right triangle, despite whatever instincts we might have about how it appears visually. Not a right triangle. Okay? If you have roots, it's fine. And as soon as you square them, they're going to cancel out. You might see a little bit of multiplication with some of these pieces as well. Okay, that's all right. We've got time to practice. We've got assignments that aren't due till Sunday, so we have plenty of time to ask questions before then. I'm going to do one more, sort of the monitoring progress stuff on that same page there. Number 4, just because it has one of those square roots, and I think that it's worth seeing another one of these guys. We're testing if it is right, so I'm just going to substitute numbers into Pythagorean theorem and go from there. It appears that my right angle would be between 9 and 15, making those two my legs. I'm going to clean that out. So I'm going to have on my right side of my equal sign a 3, let's pick a darker color, 3 times the square root of 34. All of that goes in parentheses, and then it gets squared. I'm going to bring this squared into both parts, both 3 and the root 34. Let's see what that's going to turn into. 9 squared is going to give me 81. From the last problem, 15 squared is going to give me a 225. Come on. When I bring that 3, or when I square the 3 and the root 34, I'm going to get a 3 squared times, then I have a root 34, which is a number. You can figure it out. It's a little bit underneath 6. And a 2, squaring that. Those guys are going to cross cancel completely. So my next step is going to look like 3 squared, which I'll go ahead and write as just sort of a 9. Actually, I'll just type it all out. My 3 squared was 9 times, once the square root and the square cancel out, I have times 34. Again, calculator's totally okay. Let's bring it back up. What's 81 plus 225? It's a 306. So I'm going to replace my left side with 306. Is that equal to 9 times 34? Oh, indeed. So what does that mean about this guy? This triangle is a right triangle. We now know for sure that we do have a right angle in between that 9 and 15. All right, we got another toolkit slide right here. Pythagorean inequalities. Really, this is a fancy way of basically letting us figure out if it's not a right triangle, do we know if it's going to be acute, meaning all of the angles are less than 90, or is it going to be obtuse, where it's going to have one angle greater than 90? It's the same check, except now it has a inequality in there. If your c squared portion is less than a squared plus b squared, you're going to have an acute. If the c squared portion, what would be the quote hypotenuse, but it's not, is bigger than a squared plus b squared, you have a obtuse triangle. So we're going to test it with this guy right here. We've got a 4.3 feet, a 5.2, and a 6.1. Don't be afraid of decimals. They're okay. And it should be from that next example on that next page there. The one that would be the hypotenuse, and I'm going to put a sort of question mark over this equal sign here, because we're going to basically test and see which one of these matches. Okay? If it's right, if these hold and it's equal, if c squared is greater than a squared plus b squared, we have an obtuse. If c squared is less than a squared plus b squared, we have an acute. Let's start substituting some numbers here. I'm going to put instead of a, 4.3. Instead of b, I'm going to put 5.2, because those would be the legs. They have to be the sort of two smallest, and your largest side would have to be where the hypotenuse goes. 4.3 squared plus 5.2 squared, I'm putting equals with sort of, again, this question mark over it. We're going to basically make a comparison at the end and see. What's 4.3 squared? I don't know. Let's figure it out. Oh, okay, 18.49. Calculator, again, no problems with it. So I'm going to put an 18.49. What's 5.2 squared? Go back to our trusty calculator. Just doing 5.2 times 5.2, that's all it is. 27.04. Is that going to be equal to, well, we got to figure out what 6.1 squared is. Again, calculator's totally okay. 37.21. Let's add that left side to basically kind of make our final comparison. I'm going to add 18.49 plus 27.04. I get 45.53. So if I were to now replace that equal sign, because I see they're not equal, I got a 45.53 and a 37.21. My 45.53 is definitely greater. Oops, didn't hold the shift key. Greater than a 37.21, which means back to my original statement, that Pythagorean that we were kind of testing. Ooh, sorry about that. A squared plus b squared ends up being greater than c squared. What type of triangle did that end up making? This is going to be an acute triangle. All angles are going to be less than 90 because my hypotenuse portion isn't equal or greater than this. We'll have time for you to practice some of those and some of the assignments as well. Just to check. Come back here, reference this as much as you like. Again, those sort of toolkit slides. You've got some examples and a more thorough proof if you're really interested in that as well. We can do the same thing with the 3, 4, and 6. Do this guy a little quicker than the last one. Starting basically with hey, is my Pythagorean theorem true or not? A squared plus b squared, does it equal c squared? We're going to check. 3, 4, 6 would basically be my a, b, and c. These numbers are going to be a little cleaner. We are going to probably throw some decimals at you. That's okay. Calculators are okay, just like they've been on all tests. What's my 3 squared going to be? 9. Let's do it this way. 4 squared is going to be a 16. 6 squared is going to be a 36. If I add 9 and 16, I'm going to get 25. And we know that 25 is not going to be equal to 36. It ends up being less than. So what does that mean now about my original equation? a squared plus b squared was less than c squared, if you flip this same piece around, that would look like this. C squared would end up being greater than a squared plus b squared. That was our case where we ended up having an obtuse. If your c squared, the side with like the biggest one, ends up being greater than your a squared plus b squared, you got an obtuse angle, or obtuse triangle rather. I'll leave this up here for a brief moment if you want some additional bonus practice, but you're going to get plenty in the homework. I probably would have actually taken this slide out in class. Okay, that's basically our stuff from 9.1. We're kind of jamming a lot into this video. Those of you watching on YouTube 1.5, I get it. We're going to move on to 9.2 now, where it's talking about two types of triangles here. These 45, 45, 90s, which kind of look like this left bluish one. We're going to have two angles that are going to be congruent, those 45s, and we have the 90, that nice right triangle. Let me delete some of these pieces here. Sorry, my spacing is off. And then, okay, got rid of everything. I have a 30, 60, 90 triangle, where I'm still going to have a right angle. I'm going to have one that's much bigger, which is going to end up being sort of my 60, and then my smaller angle is going to end up being 30. We care about these because these do some pretty interesting sort of properties. We're going to kind of explore those. There are, I think, kind of interesting proofs of these that you're welcome to look up. I'm not going to make you. I had to sneak some pictures of my dogs in here. This is Kona. She's a mix of basically every working dog ever. When she's sitting, she kind of exemplifies a nice, pretty 45, 45, 90 triangle. Right? You can see the angle between her like feet in the ground and the way her body moves versus her legs ends up being 45s and 45s in both cases. Obi, my other dog, is a little bit smaller than Kona, as you might be able to tell. He's got a little bit of Chihuahua in him, so he has this sort of chondrodysplasia. He got these short little legs here. He ends up sitting much more like a 30, 60, 90. What I'm going to ask you to do is remember these names, Kona and Obi. And I'm going to ask just a simple question about these as sort of proof that you have watched the video, okay? One more time, Kona was with my 45, 45, 90 triangle. Obi was with a 30, 60, 90 triangle. Both of them when they're sitting. I mean, look at this cute little face, too. These ears will pick up satellite stuff. You kidding me? Look at that thing compared to the size of the head. Still a little boy. All right, anyhow, those are my dogs, Kona and Obi. Let's actually put this to work. We've got this 45, 45, 90 triangle theorem. I'm not really going to ever expect you to say this sort of thing all the way out. Really what happens is I have my legs right here because it's still a right triangle. You notice in both cases here, these legs are listed as x. Each leg is exactly the same. They're congruent to each other. Your hypotenuse is always square root 2 times bigger than whatever your leg number is. That's it. There's some cool proofs of this sort of stuff, but let's actually just put it to use. We're asking you to find the value x here on page 526, example number 1. If we're looking at A, the two sides touching the right triangle, I know are both legs. Since both legs in a 45, 45, 90 are congruent, I know my other side here is an 8. It's not asking for it. It's good to just know. I want to find x, the hypotenuse, opposite of that 90. Go back to our formula. It's whatever my leg is, which is going to be 8, and then I'm going to multiply it by square root of 2. That's it. That's your answer. 8 square root 2 is how big this is. You can figure out a decimal value if you really wanted. You could do 8 times the square root of 2. I'm going to be okay if you just say 8 square root 2. No problems. If we move to B, we notice that both legs here are unlabeled. So if we find one, we find the other because they're both congruent. If I have the hypotenuse and I'm looking for a leg, I can almost do a little bit of algebra where I divide both sides by square root 2. So what am I going to do here? Well, x in this case is going to equal my hypotenuse, which is 5 square root of 2, and then I'm going to come along and divide it by square root 2. That's it for a 45, 45, 90. We'll get a little bit sort of spicier, kind of Monday-ish, but for now, that's all I'm really looking for. I mentioned another triangle, which was a 30, 60, 90. They have a bit trickier sort of process here. It doesn't have legs that are going to all be congruent in this case. Generally, what I look at is if you start with your shortest leg, it's going to be always the one opposite the angle. Smaller angle, smaller leg. Bigger angle, like the 90, goes with the biggest leg. Middle angle goes with the middlest leg. If I know my smallest leg, I can multiply whatever that smallest or shorter leg is by square root 3 to find out how long my longer leg is. If I know my shortest leg, I multiply that by just regular old 2 to find the hypotenuse. We can do a little bit of algebra to work with these in a couple different ways, and that's what we're going to do here on page 527, example number 2. Let's put it to use. Right now, my short leg is always the side opposite of the 30. So 30 is right here, but it's looking over here at this x. I don't know that yet. I'm going to need to know x to figure out y. Well, if we have this equation where basically like my long leg equals my shorter leg times the square root 3. Oh, goodness. That doesn't look good. We'll just jam it on at the end. Let's basically write what we know in here for this portion. I know my long leg is 9. I don't know the short, but I want to figure it out, and it's being multiplied by a square root of 3. What are we going to do to solve? Divide both sides by a square root of 3. At this point, you have, extend this a little bit, your short leg is literally 9 divided by square root 3. That's it. I'm going to show you a trick here that I could teach you a lot on why, and if you're curious, please reach out, come to office hours, we can work our way through that. This is going to be something that's not really proper form. We probably aren't going to take off if you make a mistake with that, but you don't generally leave a square root in the denominator. What I'm going to do is I'm going to move the square root up. So I'm going to write 9. I'm going to put a square root 3 on top with the 9 and divide it by. The denominator is going to basically be the same, except it's just going to keep that 3. I can prove to you why that works later if you're very interested. I'm going to use this sort of number for everything going forward, and you might see why here. What can I do with this 9 and this 3 now? I can cross cancel those. So I've got now 3 square root 3 is the short leg, which is a little easier than kind of dealing with fractions, okay? I'm going to scroll back up because we still need to find y. I can do a better line than that. What side length is y going to be? Well, it's the hypotenuse. It's twice or 2 times as big as my short leg. So what's y in this case going to be? It's going to equal 2 times the short leg. So I'm going to get y equals 2. And I'm going to put in parentheses this whole 3 square root 3. If I multiply those, I can basically multiply this 2 and this 3 together. That's going to give me 6, and then just square root 3. The 2 doesn't multiply into the square root 3 right here because they're all 3 multiplied, so that would be like multiplying by 4 instead of 2. There's your answer. You've got your short leg, which was x. You've got your long leg, which is y. You might do a little bit of algebra with those pieces. We'll have plenty of practice and sort of the homework for you. Let's do a little bit more here so you can kind of see a couple examples. I can tell my first triangle is a 45, 45, 90. We're on to page 527, the monitoring progress numbers 1, 2, and 3. I've been given the hypotenuse. I want the leg. I'm going to take my hypotenuse, pick a darker color. Every time to find the leg on a 45, 45, 90, I divide by square root 2. Those will cross cancel. What does x equal? 2. That's it. Number 2, I also know this is a 45, 45, 90 because I can tell both legs are congruent. Both legs are listed as the square root of 2. To find the hypotenuse, I'm going to take the leg, square root of 2, and I'm going to multiply by the number, square root of 2. So I could say y equals here Well, if I clean that up, I get y equals the square root of 2 squared. What can I do with that? Cross cancel those, so I just get y equals, actually in this case, just regular 2. Square root of 2 times square root of 2 is going to undo that square root. Let's look at number 3. This one is labeled 30, 60, 90. You could also kind of figure that out. Well, I guess maybe we wouldn't really necessarily know because we would have to have enough information to know for sure the legs aren't congruent. I'm given the short leg right here, which is square root 3 because it's opposite of that 30. The long leg is going to equal the short. I'm just going to I'll write out short, times the number square root of 3. So if I replace that, I've got long equals, the short leg is currently the square root of 3. I'm going to multiply it by a square root of 3. So my long leg here is going to equal the square root of 3 squared. Just like that previous problem, you might realize those are going to cross cancel. How long is the long leg really? Well, it looks more like lung. It's just going to be a 3. That's how big x is. It's not asking for the hypotenuse, but if we wanted to do that, all right, hypotenuse, it's always 2 times the short leg. We're already given the short leg, so I would just write 2. It's currently square root 3. You can't clean it up. 2 square root 3 is your number. That's it. You're done. Okay. I know that's sort of a lot. Here's your tasks for the week. You might have gotten online Google Classroom already. You're already going to see one homework assignment for 9.1. There's one homework assignment for 9.2. Both of those are due Sunday at midnight. It's listed on the Google Classroom. You're going to submit all your answers through Big Idea, just like you did for the EO8 review answers. There's going to be another quick assignment that goes in there that basically is just prove that you watched the video once I upload this. I'm going to go back one more time as a reminder for that. Kona, big dog, 45, 45, 90 triangle. OB, small dog, 30, 60, 90 triangle. You're going to need to use that information. If you watch the video, it'll be a free little thing, and that's basically a way of proving to me, hey, I watched the video, Mr. Kleepak. Monday, I'm going to have another video coming with kind of a few spicier things and maybe dealing with some larger scale questions that I got from the whole class. And you'll have your first sort of test/quiz on this coming Wednesday, a week from now. That will be done through Exam Login, and that's going to be sort of a weekly cycle where we're going to give you like sort of 1 unit usually. This first one's kind of 2. It was 9.1 and 9.2, but after that, it's going to basically be 1 section, 1 quiz on that. Your average of all those is going to make your final Unit 9 grade, and we're going to have one that kind of is cumulative as well, okay? Take your time with those. You can use any sort of resources you might need. If you build a toolkit, if you were to come back and watch some of these, if you were to use your homework calculators, all that stuff's good to go. Hope you're staying well, staying busy, staying as healthy as you can. Make certain you get outside periodically. I actually see a little bit of this. I realize the irony as I sit in a dark room. But yeah, before we get that snow, enjoy some of the time. And I appreciate everything. We'll talk to y'all later. Don't be afraid to drop into those office hours. There's 2 hours every day where I'm just sitting waiting for people to come ask questions to get help. It's the best way to kind of get immediate response on some of these things because the emails can kind of pile up and I have little times where I'm able to kind of knock those out. Come to office hours if you got questions. We'll see you.